All right. Everyone can see my screen? Okay. All right, so Team AutoMagic, it's me, Sonu, and Mukesh. So here's our model training pipeline with Tensorflow. First step was collect and annotate data, which we talked about last time. Then split the data into train and test samples and generate the TF records from the split. Next, we set up a config file and label map, and then we can train with TensorFlow. Then we'll export the model and test it on our test data. So just to review, we did collect and annotate data. We had around 1,300 photos that were annotated with Label Me. That was my team, Team AutoMagic, and also Team NeuroKnights working together. So good job, everyone. Next, we moved all of our annotation data to a Google storage bucket, thanks to Sonu. He created that for us. So great job on that. It's been very helpful. And then everyone from my team and Team NeuroKnights uploaded their data. Thanks to Mukesh, because Rosen was unavailable yesterday, so I think he was the one that uploaded it for him. So we got all the data onto the bucket. So for the teams that aren't using this bucket, here's kind of what it looks like. Here's our bucket. We have all our folders and different files in here. And then we're able to copy those into the instance and use any of the data that we need from there. So the next step was to split the data into train and test samples. So I wrote a short script that puts 90% of them into a train folder. That's 1186, and then the other 10% we'll test. We'll start with that 90-10, and maybe if we need to adjust, we can adjust. But next is generate the TF records. So we have a script that will generate that. Well, it's a two-step process, really. First, we take the XML files, convert them to a CSV, and then that CSV can be converted into TF records. One thing right now, currently, any polygons are just being changed into rectangles. So just with what I was working with, that's what we've been able to do for now. But maybe later on down the road, we can find out how to incorporate the polygons. And but for now, everything is just as a rectangle, which is fine to start. So step 4, we'll set up a config file and label map. So to start, we're going to use SSD, MobileNet, Coco, because it's fast, so we can train it quickly. And then we'll just modify a config file that's used that before. Then create a label map. So you can see over here, every item has an ID number and a name. So this is what you'll see when it's trained. If it's a car, truck, bus, motorbike, auto, person, animal. And then Mukesh last meeting brought up a good point of why aren't we using pre-trained models, because there are already models that can identify cars and trucks and buses. So we're going to look into how to use that, and then on top of that, use our own annotated data as well, so we can get things like autos and stuff like that in our model as well. So then we'll run TensorFlow. I started on the CPU and it was very slow, and we'll have to run it on the GPU so that we can learn faster, but it just step by step goes through, and you're just hoping this loss will just keep decreasing as it learns. So that's our next step. So what we're going to complete by the deadline, we'll train it with TensorFlow, we'll export that and test, and then our team will work together after we'll work together to get the model trained on the GPU, and then we can make any adjustments based on what we're seeing from our test data, and go back and work on the model from there. And if time allows, we'll start looking into using Keras to implement the model. So I think that's it for me. Are there any questions or anything?
Hello.
Yep. I mean, I think like the test set is kind of serves as our validation, and then we can run it on new data, and that will be like the true test. Are you asking like what do I expect, or? No, I haven't gotten it trained on the GPU. I tried on the CPU, but it was very slow, and so I'm gonna now go and train it on the GPU, and then I'll be able to let you know how accurate we were.
Yes, I have a question. Hello.
Yep.
Yeah, actually, like what I'm asking, that if like in a each image, if there are like a lot of objects like a truck or a car or trees or any other thing, so we can say like those objects are kind of like a cluttered, like clustered kind of thing. So in that case, does your model can be able to detect them like separately, or there may be some problem regarding that clutteredness or something?
It should be able to identify them separately.
Actually, like like if there is kind of any traffic jam or lot of cars or trucks actually like came to the like face of the camera which is installed in the car, so in that case when there may be many like chances like a car or a truck actually block any other object, so then like your model can be able to like extract the features from that, and there may be a case that it can be able to like detect the object or also like detect the like right class of the object. So in that case, like what should do, or like what kind of reason we can take?
So yeah, good question. So the annotation process we did had an option for whether it was occluded, which meant that it was being blocked by something in front of it or something like that. So I haven't yet. We'll have to see how this model does, but we'll have to look into how we can take that into account. So when there's multiple cars and things blocking other cars and stuff, then we did annotate the data to account for that. So second kind.
Yeah, kind of. Actually, because like still now it's like that the challenge is now is not actually solved by many other labs also, because I actually like taking a course from actually that is actually provided by the MIT. Okay, so in that course actually there is kind of some problems regarding that kind of issues, like if there is some kind of cluttered objects, or maybe those cars, or those trucks, if they actually have more speed than our vehicle. So in that case what is happened, like they can't be able to track that the truck or the car correctly, and also classify them correctly, because the response type became higher than their speed or something. Okay, and for the clutterness there also actually I also have some problem. So like basically, so like I actually I think actually I see one lab, actually that lab is from Germany. So they actually did one kind of very like intelligent thing. So what they have done is like they actually replace those kind of objects with a very simple kind of object. Okay, like if we have a truck, they actually replace that with a cube having a kind of like estimated size for that. So in that way, they actually don't have to calculate the whole thing for like planning or something. Okay, and they actually kind of just like detect them using that, because we only need to just avoid those obstacles, so that we can't be able to have any accident or something. So yeah. Okay.
Yeah, and if you have any resources on that, be sure and share them in the resources in Slack, because we would all like to read that
Yeah,
stuff.
yeah, sure.
Yeah, thanks.
Okay.
Yes, can you hear me?
Yeah.
Okay,